Okay, so the next thing we're going to take a look at here is the modulus of a complex number, or the length of the complex number. Okay, so the modulus, or the length of the complex number from the origin. Okay, so here's our complex number here. This complex number is -4. So over -4 on the real axis and up 3 on the imaginary axis. So there's my complex number. So the modulus of it is the length of it here. Now it's very, very easy to see. Now we put two vertical lines alongside it like this. So the modulus of a complex number is the square root of a squared plus b squared. Now you'll notice, do not put the I in here, because that would give you an I squared and give you a minus in the middle. Remember, that I is just to let you know that that part is imaginary when it's here with a real part. When we look at our diagram then, we should be able to see that this part here on the bottom is our A, our length of A, and this part here is our length B. So what you can see is, obviously then, if I was to just make a triangle here and here, that I've formed a right angle triangle. So all you're using is Pythagoras' theorem. Okay, so this here is how we refer to that as the length of the complex number z. So the length of the complex number using Pythagoras' theorem would be that the length squared would be equal to a squared plus b squared. That's simply Pythagoras' theorem. The hypotenuse, which is the length of the complex number here, is equal to the square of the sum of the other two sides. So that means our z is equal to the square root, the length of our z, sorry, is equal to the square root of a squared plus b squared. And that's the formula that we use. So in this case here, our number was, this number here, z, is equal to -4 plus 3i. So if we look here, there's our number, z equals -4 plus 3i. The length of that is equal to this thing squared plus 3 squared. Now, there are some properties of it that are very important and very handy. So if you have a complex number here, z1, divided by z2, and you want to find the length of that, what's this telling you is that you would have to, this tells you on the left that you need to divide the two complex numbers by doing that awkward method that we've used earlier on, and then get the length of that complex number. But the rule here tells us that you can get the length of the top complex number, get the length of the bottom complex number, and divide them, and that's the same thing. And it's far easier to get the length of a complex number than to actually have to do a division first. Okay, and this is this. Now, obviously here, the length of a real number from the origin is obviously just that number. Okay, so the length of 1 from the origin 1 is 1. The length of 3, so look at, there's 1. Okay, so clearly it's 1 away from the origin. If there was a 3 on top, its length would be 3. So the length of real numbers is the same as the actual number. And here this just means that you just need to divide by the length of z2. Okay, so let's try an example. So it says, given that z is equal to 2 plus I, calculate this thing here. Okay, so we've z squared minus z plus 3. So the first thing we're going to have to do with this thing here is we're going to have to multiply it out until it gets into a number that says a plus bi. Okay, so that's the first thing we need to do. We need to work this thing out before we get as far as there. Okay, so what I have here is I'm going to first of all work out what z squared is. So z squared will equal 2 plus I to be squared. Actually, look, I'll just do it all together actually, so it'll be a little different than the example in the notes. So I'll do z squared minus z plus 3, which is going to be equal to 2 plus I squared minus 2 plus I, and then I have a plus 3. Okay, so that's equal to 4. So square the first, twice the product, 4i plus I squared. Now be very careful here when you're distributing your negative. So we get -2, -i, and then we'll have plus 3. Now, next thing I'm going to do here is I'm going to change this I squared into -1. So 4 plus 4i minus 1 minus 2 minus I plus 3. Now, bringing all your real parts together and imaginary parts, so 4 minus 1 minus 2 and 3, so that's 7 minus 3, which is back to 4. And then 4i minus I is 4 plus 3i. Okay, now, 4 plus 3i. Okay, so the next thing then I need to do is I need to find the length of that complex number. Okay, so the length of that complex number is the length of 4 plus 3i, which is equal to the square root of 4 squared plus 3 squared, which again is equal to the square root of 25, which is equal to 5. Now, you'll notice here it has the exact same length as the one above because it's just a different alternation of the numbers 4 and 3. So if you kind of think about this, all of these okay, and then swapping those around. Okay, so they will all have a modulus of 5. Okay, because they all have a combination of 4 and 3. The signs don't matter. It doesn't matter whether it's on the real or the imaginary, because there are two sides of the triangle, and the third side will be the length of the hypotenuse. Now note in the example here, again, I've made a mistake in the handout, because in your notes here, and I'll just correct them. We have, okay, sorry, it's above that. In your notes here, I have the number 2 plus I in the question, but then I use 2 minus I down here. So I'll just change that to a plus, and that will be a plus, and that will be a minus, and that'll give me 4, and that's a plus, that'll give me 4 plus 3i. Okay, and I get the same answer.